Hi, everyone. My name is Nicole Emerson, and I'm joined today by Jessica Jensen, Daniel Villa, and Christina Ludwicki, who are industry process consultants within the GEOVIA brand. So as mentioned, our presenters for today are Jessica Jensen and Daniel Villa, who are both industry process consultants. Their role is focused on supporting the value engagement process with customers who are engaging in a digital transformation journey. Jessica has 18 years experience in industrial enterprise software with a focus on product strategy and business value definition for workforce management, short-term scheduling, optimization, and execution. Daniel is a mining engineer with 20 years experience with a focus in block and sub-level caving, including both feasibility studies and operating mines.
Let's start by taking a quick look at the entire mining solution portfolio from Dassault Systèmes, which was created to address the challenges and needs of the mining industry across the entire value chain. There are three portfolios that cover the life cycles of key aspects of a mining business. These include the capital facilities and project lifecycle management, the resources lifecycle management, and the operations lifecycle management. Each of these portfolios is made up of a set of industry solution experiences. For example, the first portfolio covers the lifecycle of the physical assets of a mining business, such as the process plant or mill, or the entire fleet of heavy mining equipment. The second portfolio addresses the lifecycle of the mine's resources. This includes the geological and resource models, as well as the mine designs and plans. And we're going to focus in on this area for the rest of the presentation. Finally, the third portfolio covers the life cycle of the operations that make up the mining business. So that includes things like the short-term mining schedules, the milling and smelting schedules, or the shipping schedules, and the monitoring of all of these combined schedules. Each of the industry solution experiences within these portfolios are made up of processes. These are process workflows that enable you to deliver specific outputs, for example, a validated geological model or a resource model or mine plan. The industry solution and process experiences help you to implement best practices, to standardize those practices across your operations and ensure stability, and in doing so, to develop excellence in becoming an agile business. Now let's delve into the second portfolio, which is Resources Lifecycle Management. It's made up of several industry solution experiences, including resource portfolio evaluation and modeling, strategic mine planning and design, and mine to customer tactical planning. Within mine to customer tactical planning, there are several process experiences, and the one we're going to focus on today is tactical mine planning. The objective of tactical mine planning is to create automated and optimized tactical plans to guide execution assignment and optimally respond to predicted or actual events as they occur, all while maximizing your profits and reducing your costs. So let's dig a little deeper into tactical mine planning.
The tactical mine planning industry process experience develop automated and optimized caving schedule, combining development and production result. In terms of benefit, we can describe the following. Improve productivity profit by achieving scheduling objectives by quickly create and analyze multiple scenarios, reducing mining costs by preparing practical schedule specifically designed by using caving rules, constraints, and production targets. Improve mill forecasting by comparison of actual versus forecast geological condition per draw point. Validate the schedule by visualizing them in 3D animation and incorporating caving geomechanics simulation into the mine planning process. This workflow is made of 6 business processes, and all of them will be detailed in this presentation. Finally, this methodology has been brought into the 3D experience platform, providing full governance of the mine planning process, improved by simulation and analytic of the result, and finally, better collaboration, communication, and visibility to all stakeholders. The first business process is the definition of objective, KPI, and constraint. It is the foundation of the work, since enable to collect all the required information, including historical data, such as tonnage and grade extracted. At this stage, also, leverage the collaborative nature of the platform to finalize key input parameters by communicating with team members and also by accessing relevant market news. Let's now see the defined objective in action. The process starts by logging into the 3D Experience platform. Once we're inside, we can review the overall status of the project and beginning by activating a specific task for defined objective. Then we can analyze relevant mining news, trends, and feeds. In this case, potential impact of COVID-19 and another topic, all relevant news relative to the copper project. At this point, we begin collaborating with our colleague on key decisions. In this case, using communities or groups to discuss which gold price will be used in this analysis. Then we can manage and update relevant project data. In this example, we begin checking out a key parameter file, then update this value to be used in this tactical plan. For example, metal price. And this is where uncertainty modeling of potential distribution of value take place in this process. At this stage, we complete the task of define objective and move this task to the done status. The second business process is to generate a tactical mine plan. This enables to incorporate general mine status by bringing actual data, geotechnical constraint, and risk to produce feasible tactical plan. Allow for complex modeling of various scenarios in block caving and sub-level caving, powerful integration between Minesheet and PCSLC, allow for easy scheduling of development, production extraction, and predicted grade. The benefit for the customer includes improving accuracy of the plan and reducing the time to complete tactical mine plan. In the next video, 2 examples will be shown for block and sub-level caving to illustrate these solution capabilities. Now, we will create a production schedule for a block caving mine by importing the latest actual data to have all the information of previous month extracted. After that, we will be able to visualize the status of a draw point by preparing the inputs for the next forecast. In here, we'll be able to update the inputs where we can combine the month previously extracted and the periods used in the next forecast. Also by controlling the number of new draw points that will be incorporated in this run by using the sequence and inputs specifically defined for the next forecast. After the production run is done, we can visualize the result in Excel, where we can simply take the tons and grade extracted for every period, and also visualizing more detailed information for every single draw point. For example, the tons extracted, or even the height of draw reported. Playback tool gives us the opportunity to visualize graphically in 3D the data reported in this plan, where we can see the combination of the past and the future forecast. In this example, we will see what is the result of the tactical mine plan done for a sublevel cave-in mine, where we can combine data from PCSLC as a single ring data and the development plan created in Mindship. As we can see here, in Mindship, we receive the information from PCSLC, loading all the design and ring to do a full analysis. After the design is loaded and the data from PCSLC is brought into Mindship, we can see for every tunnel the detailed information created per ring. Precedent will be automatically set, and then we will have a full integrated result combining data from production from PCSLC and the development created in Mindship. The third business process is to perform cave simulation. Fine element simulation allows for prediction of the cave-back geometry and the propagation of the cave-in mine with the integration of geotechnical constraint and the cave-in simulation. This is done using powerful coupling between leading industry software PCBC and Abacus to break down the silos between departments and increase transparency and confidence in the model. This allows to understand and calibrate the cave-back prediction by bringing actual data, update cave-back height and potential breakthrough, understand the impact of mining in the surrounding infrastructure, increase flexibility to update the model in response of deviation from the original strategic plan, and the benefit for the customer includes improving safety by having better understanding of the propagation of the cave, the ability to achieve target mine plan, and reducing risk in detail in mining project by minimizing time to analyze new scenarios. Let's now see the cave flow simulation in action. The first step is to import the latest information from the mine so we can work with the latest extraction of the tons for every draw point. This will be done using cellular automaton as an advanced flow model, where we can work with physical input that can be modified after by Abacus during the run. Here is where the advanced profile control most of the inputs for cellular automaton, but also this gives us the option to couple with Abacus by simply enabling the option to send information back and forth between those two systems. As you can see here, the connection is done through executable script that are automatically created and run behind the scene, so the user will not have access and visualization of this. Now we will be able to run cellular automaton as we normally do, but the result will be linked automatically and internally with Abacus to generate analysis as a cave propagation. As you can see here, during the extraction and the simulation done by cellular automaton, information is sent automatically to Abacus, where Abacus will do all the stress analysis internally and returning data to CA3D. information that can be displayed automatically in parallel with Abacus, can be displaying physical result at the principal stress, and even quantify what is the breaking through of the surface, or how the stresses are built when you have two K-front advancing simultaneously. Another way to visualize this is the result of the volume of the rock under high stress. Finally, the result is sent back to CA3D and create an Excel report as we normally do, so you can do further analysis to investigate the effect of the K-flow simulation. Now we go to the fourth business process, the scenario analysis and optimization, where we can optimize mill feed from multiple sectors and multiple mines, plans and coordinate new GEOVIA in conjunction with development activities, determine the correlation between original estimation and simulation to actuals, and define possible contingency for maintenance development plan. The benefit for the customer includes maximize NPV realized, increase scenario options to achieve plan, better understanding of correlation between simulation and historical mining, and reduce design rework. Let's have a look at this business process video. In this scenario analysis and optimization video, we use Process Composer for the analysis of multiple scenarios automatically, defining variable to change during this grade calibration. This parameter from Process Composer override inputs allowing multiple run automatically by copying into the block A folder. This execution is run automatically, setting parameters from CA3D, executable link from Excel, and running scenarios with all appropriate profiles. This optimization can be executed from Process Composer on 3D Experience, automatically launching many scenarios for the analysis, and the result can be retrieved from Block A folder project, where this allows mapping the output such as tons, grade, data from the simulation, and comparing with the actual data. The design of the experiment allows parameters to be modified and set up as a matrix, where different scenarios could be defined, combining multiple inputs, in this example changing mixing parameters. In the Response tab, it's defined which relevant variable will be analyzed, and we can assign different weight to the variable result. The analysis of multiple run is done using Process Composer, launching CA3D automatically and running with a set of the parameter defined at the design of experiment. The result from complete job is available on the 3D Experience Result Analytic, where we can easily change the priority and weight of the parameter of the result, where we can compare, select, and filter our favorite result into a basket for further analysis. Once you have found your favorite option, you can select and share it for collaboration with your team members. This business process enabled the option to bring data from caving production schedule into the 3D Experience platform, so we can easily analyze multiple scenarios with different draw strategies used to create the forecast and compare with actual data. This provides better visibility and transparency of the result by improving the identification of issues or better understanding of the impact of the change in input parameters, reducing time to analyze different alternatives. All this is done using the 3D Experience platform, providing better collaboration, communication, and visibility. In this example, it's possible to see results from production schedule created in PCVC. For example, being able to compare 3 different alternatives with a typical production plan, calculate difference, and highlight different KPIs. Additionally, we can visualize grade from the actual data compared with the forecast and the projection for the future. Same analysis can be done with the tons extracted versus the ton forecasted and how the trend it's looking for the future. Finally, detailed result of this production schedule also can be brought into the 3D Experience platform, as you can see in here, and comparing with the actual production data. The final business process is around collaboration and share. Here, we can share and collaborate data through central location across multiple departments and to key stakeholders using 3D Experience platform. Dashboards illustrating key KPIs can be used for easy access and visualization for current mine status with key stakeholders. And finally, we can allow the user to quickly evaluate and interrogate historical data to ensure the plan is accurate and achievable. The benefits for the customer are increased collaboration between departments, improved stakeholders and executive understanding, and reducing time to react to variation in the plan. Let's now see how the collaboration and share is in action. The process starts by logging into the 3D Experience platform. Once we are inside, we can review any type of information. For example, comparing actual and forecast data done by Drawpoint and publishing this analysis into a community, allowing to share with other team members easy and quickly. This can include a visualization of 3D surface created in PCVC or to display data from a Drawpoint. New file can be easily included and shared to have better visibility and understanding of the data. By adding annotation, we can publish those images into a community to get feedback from your team members to be sure that the data utilized is correct, improving collaboration between departments. All this will be done using 3D Experience platform, improving traceability of this information, since this type of communication is normally done by email only, where frequently get lost. Additionally, it's possible to share another type of information obtained from the news that can be useful for this task or project. Also, specific data could be published to provide official results to stakeholders to improve their understanding and getting their feedback. Finally, to facilitate your interaction with the rest of the team, you can use the same information into a conversation. By doing this, you will be able to get quick response and reduce the time to react in case the data used is not correct or the latest. With this, we conclude the dashboard presentation for Tactical Mine Plan.